Now we know that a resistance is nothing but the property of conductor due to which it opposes the flow of current through the conductor, right? Now let's look at the factors upon which the resistance of a conductor depends. So the electrical resistance of a conductor depends on the length of the conductor. It means the resistance is directly proportional to the length of the conductor. Resistance is inversely proportional to the area of cross section, and resistance is depends on the nature of the material. Resistance depends on temperature. Now let's first look at the length of the conductor. It has found by experiments that on increasing the length of wire, it means the long wire, it's when you are increasing the length of the wire, its resistance also increases. It means larger the length of the wire, this is L length, larger the length of the wire, that means that will have greater resistance. And if we decrease the length of the wire, this is a short wire, then what happens? Resistance is also low. So that is why resistance is said to be directly proportional to length of the wire. R is directly proportional to the length. Now let's talk about the area of cross section. Now again, it has been found by experiments that the resistance of a conductor is inversely proportional to the area of cross section. That means what is the area of cross section? That is basically the area of the circular portion. Okay. Now see, if this area increases, if this area gets doubled, resistance decreases, resistance gets halved. So it means if you are having a thick wire, it means the area of cross section is more there. And in that case, you will have low resistance. In case of larger area, it means thick wires like this. And in case of thin wires, that means the area is less, then in that case you will have greater resistance. So it means resistance is inversely proportional to the area of cross section. That's why I have written here 1 by A, because it's inverse proportion. So if area increases, resistance decreases, and if area decreases, resistance increases. And the next factor upon which resistance depends, that is nature of the material. Now see, the resistance depends on this nature of the material of which the material is made. Now see what happens, some materials have low resistance and some have very high resistance. For instance, if you take two similar wires having equal lengths, having same diameters, then what will happen? Suppose you are having two wires, say of copper and nichrome. Copper is a metal, nichrome is an alloy, okay, and both have same length and same diameter, same areas. Now you will see that the resistance of nichrome is 60 times more than copper wire. So if resistance of nichrome is more, then definitely less amount of current will flow through the nichrome. And while as in case of copper, resistance is less, so that means more current will flow in case of copper. So that is because of the material, because that those two wires, material of which those two wires are made. Copper is made of a copper wire is made of a copper metal, and nichrome wire is made of nichrome alloy. Because of this material, because of the nature of this material, resistance changes. Okay. And the other factor upon which resistance depends, that is temperature. Again, what happens, it has been found that resistance of pure metals, that means of copper, aluminum, resistance of pure metals increases on raising the temperature and decreases on lowering the temperature, on decreasing the temperature. But in case of alloys, resistance, in case of alloys like nichrome, manganese, what happens? Resistance is almost unaffected by temperature. Temperature doesn't play any role there in case of resistance, in case of alloys, okay? Now, as per these two equations, if we combine these two equations, what happens? Resistance C is directly proportional to length, resistance is inversely proportional to area. Now, if we combine these two, we will get R is equal to rho, this is read as rho, L divided by A, that is length divided by area of cross section. Now what is this rho? Again, this is a constant, and this rho is known as resistivity of material, resistivity of a substance. Okay. Now this resistivity of a substance, it is just similar to resistance. It is also a characteristic, a fundamental property of material that resists the flow of electric current. So we can use this resistivity values of different substances to compare the resistances of two or more substances. We can use this resistivity value to compare the resistances. Okay. And this resistivity, it does not depend on length and thickness. As you saw in resistance depends on length and area, but resistivity does not depend on length and length or thickness. Yeah, it depends on the nature of the substance and temperature. Okay. Now let's look at the units of resistivity. Now see, if we derive the formula for resistivity from this equation, keep resistivity as it is. If L by A is transposed to here left hand side, then what happens? It would be rho is would be equal to resistance into area divided by L, because area is in the denominator. It will get when it is transposed here, it will come in the numerator, and length will come in the denominator. So you will get rho is equal to resistance into area divided by length. Now let's check out the units for resistivity. We saw the unit for resistance was ohm, right? Now let's look for resistivity. See, resistance of unit of resistance is ohm, so represented by this symbol omega. Unit of area is meter square, because area has the unit of meter square, it's always measured in meter square, and the unit of length is meter. Now 1 meter and 1 meter will get cancelled out, and you will remain with ohm meter. So unit of resistivity is ohm meter. Okay. Now let's talk some more things about resistivity. See, it's again a constant term, and because of this resistivity we can compare the resistances of different substances. Range of resistivity of metals and alloys is almost 10 raised power minus 8 to 10 raised power minus 6 ohm meter. This is the range of resistivity of metals as well as alloys. So if we take any metal, suppose if we talk about silver has the lowest resistivity, that is of 1.60 into 10 raised power minus 8 ohm meter. That means silver offers the least resistance to the flow of current, and that is why silver is the best conductor of electricity. Okay. And but we should not make, but we can't use silver in our wiring, because silver is very costly metal, right? So we use copper and aluminum wires for the transmission of electricity, because copper and aluminum also have very low resistivity, and that is why they are also good conductors. They have a very low value of resistivity under this range. Okay. And if we talk about alloys, yeah, alloys have some high value of resistivity than pure metals. For instance, if we talk about the resistivity of mangan is an alloy that is made of copper, manganese and nickel. If we see its resistivity, that is almost 25 times more than copper. So, and if we see the resistivity of constant, another alloy made of copper and nickel, that constant has resistivity 30 times more than copper metal. So because of their high resistivity, these alloys are usually used to make resistance wires. Okay. Now the range of resistivity of non-metals, that means insulators in which electric current is not flowing, their range of resistivity is almost 10 raised power to 10 raised power 12 to 10 raised power 17 ohm meter. That means very large, and that is why current does not flow in insulators, because their resistivity value is very large. Okay. Copper and aluminum are used for electrical transmission, as they have low resistivity. As I told you about this, because they are having low resistivity values. That is why we use copper and aluminum in our transmission wires. Alloys are used in electrical heating devices. Again, I discussed this point because the resistivity is high and they do not burn readily. That is why they are used in heating devices. Okay, this was all about resistivity. Now we across this, when we move further in this chapter, we will get introduced with this term resistor. Now, what is a resistor? A resistor is an electrical component that limit or regulate the electric current. And a resistor is anything that electricity can't travel through it easily. That means a resistor is nothing but any kind of appliance, any kind of substance through which electric current cannot travel easily, through which electrons cannot flow easily. It means it limits the electric current. It doesn't allow the electricity to flow through it. So that substances are termed as resistors. And if we look at its examples, if you are having fan, bulb, television, so these are all resistance because they limit the flow of electrons. They do not allow the electricity to flow through them easily. And this was all about the resistance and resistivity.